Okay, hello guys again. I just took a little break from coffee. Oh, I just took a break, took some coffee, then did some exercises. Now I'm ready to tackle the next module. This is networking core protocols. So without further ado, let's do it. Join room. Let's give it a like TryHackMe. Okay, this room is the third room in a series of 4 rooms about computer networking. Room prerequisites, yeah, the benefits, yeah, we've already completed those prerequisites, so we completed the previous rooms. Learning objectives. By the time you finish this room, you'll have learned about the following protocols: WHOIS, DNS, HTTP and FTP, SMTP, POP3, and IMAP. Click on the Start Machine, the Start Attack Box button at the top, and click on the Start Machine button below to start the attached virtual machine. Okay, let's do it. Give them about 2 to 3 minutes to boot up. Once the two machines are ready, we need to start the terminal on the attack box to follow along, starting with task 4. Okay, so let's get task 2 completed. Do you DNS remembering addresses, right? Do you remember the IP address of your favorite websites? No, I don't. Unless it is a private IP address of a local device, no one needs to worry about memorizing IP addresses. This is in part due to the domain name system, which is responsible for properly mapping a domain name to an IP address. DNS operates at the application layer, layer 7, of the ISO OC model. DNS traffic uses UDP port 53 by default and TCP port 53 as a default fallback. There are many types of DNS records. However, in this task, we will focus on the following 4. A record. The A address record maps a hostname to one or more IPv4 addresses. For example, you can set example.com to resolve to this particular IP address. AA records. So the 4 times A record is similar to the A record, but it is for IPv6. Remember that it is AAAA, quad A, yeah, as AA and AAA would refer to the battery size. Furthermore, AAA refers to authentication, authorization, and accounting. Neither falls under DNS. Neither, yeah, okay. CNAME record. The CNAME canonical name record maps a domain name to another domain name. For example, example.com can be mapped to just example.com, right? Or even to example.org. Okay, MX record. The MX mail exchange record specifies the mail server responsible for handling emails for a domain. Okay, in other words, when you type example.com in your browser tries to resolve this domain name by querying the DNS server for the A record. However, when you try to send an email to test.example.com, the mail server would query the DNS server to find the MX record. If you want to look up the IP address of a domain from the command line, you can use tools such as nslookup. Consider the example in the terminal below where we look up example.com. Okay, nslookup, non-authoritative answer, and this is the address. Okay, the query above led to 4 packets. So what is this? Okay, nslookup example.com. Okay. The query above led to 4 packets. In the terminal below, we can see that the first and third packets send DNS queries for the A and what was it? Quad A, yeah, records respectively. The second and fourth packets show the DNS query responses. Okay. So the first one, DNS standard query, example.com. Yeah, okay. So which DNS record type refers to IPv6? Which DNS record type refers the 4 times the quad A, right? Which DNS record type refers to the email server? That is the MX records, right? Yeah, WHOIS. In the previous task, we covered how a domain name is resolved into an IP address. However, for this to happen, someone needs to have the authority to set the A, quad A, and MX records, among other DNS records for the domain. Whoever registers a domain name is granted this power. Therefore, if you register example.com, you can set any valid DNS records for example.com. You can register any available domain name for 1 or more years. You need to pay the annual fee, and you're required to provide accurate contact information as the registrant. This information is part of the data available via WHOIS records and is available publicly. Although written in uppercase, WHOIS is not an acronym, it is pronounced WHOIS. However, don't worry if you want to register a domain without revealing your contact information publicly. You can use one of the privacy services that hide all your information from the WHOIS records. You can look up the WHOIS records of any registered domain name using one of the online services or via the command line tool WHOIS available on Linux systems, among others. As expected, a WHOIS record provides information about the entity that registered the domain name, including name, phone number, email, and address. In the screenshot shown below, you can see when the record was first created and when it was last updated. Moreover, you can find the registrant's name, address, phone, and email. In the terminal output below, we have used the WHOIS command to look up a domain whose WHOIS record is protected by privacy protection. Okay, and we do get that information, huh? When was the x.com record created? Okay, WHOIS x.com. When was that created? Only Elon knows. Creation date. We got it. Creation date. But I don't think I will be able to copy it. I think delete that. Oh, what? Okay, that was it. When was the Twitter.com record created? Provide the answer in. Okay. Twitter. The Twitter was created on this date, 2021, right? Yeah, okay. HTTPS accessing the web. When you fire up your browser, you mainly use HTTP and HTTPS protocols. HTTPS stands for Hypertext Transfer Protocol, and the S in HTTPS stands for secure. This protocol relies on TCP and defines how your web browser communicates with the web server. Some of the commands or methods that your web browser commonly issues to the web server are get, retrieves data from the server, such as an HTML file or an image file. Post allows us to submit new data to the server, such as submitting a form or uploading a file. Put is used to create a new resource on the server and to update and overwriting existing information. Delete, as the name suggests, is used to delete a specified file or resource on the server. Yeah, all clear. HTTP and HTTPS commonly use TCP ports 80 and 443 respectively. Yeah, 80 for the normal HTTP and for the secure one, and 443. And less commonly other ports such as 8080 and 8443. Okay, in the following example, we use our Firefox browser to access the web server on our browser fetches the web page and displays it perfectly. However, we're interested in what happens behind the scenes, the art of espresso. Okay, so what if just we try to access? We should be able to access, right? Yeah, the art of espresso. Okay, or fetches the web page and displays it perfectly. However, we're interested in what happens behind the scenes. What is it that happens behind the scenes? Oh, there's no certificates I can see. Connection not secure, so there's only an HTTP request. Using Wireshark, we can examine the exchange between the Firefox browser and the web server more closely. The screenshot below from Wireshark shows the text sent by our browser in red and the web server response in blue. As you can tell, a lot of information is exchanged between the client and the server that does not get rendered to the user. Examples include the web server version and when the page was last modified. Okay. As you remember from networking concepts, we use the telnet client to connect to the web server running on, this one at port 80. We had sent a couple of lines, get HTTP1 and host anything to get the page we wanted. On some servers, you might get the file without sending host anything. Yeah, you can use this method to access any page and not just the default page. To get file.html, you would send get file.html HTTP1. Okay, for instance, get file might work depending on the web server in use. This approach is efficient for troubleshooting as you will be talking HTTP with the server. Use telnet to access the file flag HTML on. Okay, so telnet and then 1010 to 2.8 and then I guess 80 because it's an HTML escape character. Yeah, so yeah, I don't want to escape. Okay, so what if I just type in, what is it that I have to, black.html? Do I get anything? No, I don't. Get my word depending on the web server. It's not working. escape character is, okay. So what if I just look at file.html? No, it's not file, it's flag. HTML, and then I guess HTTP 1.1 invalid command. What is a hidden flag? Use telnet to access the file. Flag HTML. What am I doing wrong? What am I doing wrong? What am I doing wrong? As you remember from now, we use telnet to client connect, yeah, at port 80, which is the port that I specified here as well. We had to send a couple of lines, get HTTP and host anything to get the page we wanted. You might get the file without sending host anything. Okay, so I probably should be sending that host for this one, I guess. Right? So what if I, but get is not a recognized command. HTTP 1.1. I don't know. Get anything. What am I doing wrong? You would send get but okay, so if I access this one, what if I just flag.html? Get nothing. There's a hidden message here. Allow me to ask Grok how to do it. Grok is the AI from Twitter. Grok or X, right? I'm getting okay, so how do I go about that? Seems there's some misunderstanding how to use telnet to send HTTP requests. Okay, here's how you should interact. So I connect to it, as I have telnet 10.10.2.8 and then 80. Escape character. Once controlled, you should immediately start typing your HTTP request. Host anything. The command like should be sent directly to the server, not enters if they were telnet commands. So you should type get flag. Okay, without escaping. Okay, HTTP 1.1. What do we get? Nothing. Oh, okay, yes. So what is the flag? We don't have no flag. I don't see no. What should I be looking for? There should be a flag. Content, title, bad request. Why do I get bad request? Probably because I should have. Oh. Okay, let's do it again. So what if I just flag.html, HTTP 1.1, then host anything, then press enter twice. And then we don't get that same error. And where is my flag? Oh, I found my flag. DHM telnet HTTP. Okay, so I understand better now how to use telnet to issue commands. Okay, we got it. We got it with a little bit of help from Grok, you know. We'll see. All right, next one. FTP transferring files. Okay, I've done this before. Unlike HTTP, which is designed to retrieve web pages, file transfer protocols. Protocol is designed to transfer files. As a result, FTP is very efficient for file transfer, and when all conditions are equal, it can achieve higher speeds than HTTP. Okay, example commands defined by FTP protocol are: user is used to input the username, pass is used to enter the password, retrieve is used to download a file from the FTP server to the client. Store is used to upload a file from the client to the FTP server. FTP server listens on TCP port 21 by default. Data transfer is conducted via another connection from the client to the server. In the terminal below, we executed the command FTP to connect to the remote FTP server using the local FTP client. Then we went through the following steps. We use the username anonymous to log in. We didn't need to provide any password. Issuing ls return the list of files available for download. Type ASCII, switch to ASCII mode as this is a text file. Get coffee.txt allowed us to retrieve the file we want. The command exchange via FTP client shown in the terminal below. You connect to FTP, okay, to the server, then you log in. Anonymous, no password needed. You successfully log in, and then you ls, you show the files that we have here, and then okay, you type ASCII, switch into ASCII mode, and then get coffee.txt, coffee.txt remote, okay, entering passive mode data, okay. And then what did you do? Yeah, you downloaded it, right? Okay, next, we use Wireshark to examine the exchange messages more closely. The client's messages are in red, yeah, while the server's responses are in blue. Notice how various commands differ between the client and the server. For example, when you type ls on the client sends list to the server. One last thing to know is that the directory listing and the file we downloaded are sent over a separate connection each. Okay, using FTP client on the attack box. Okay, FTP 10.10.2.8. Using this on the attack box, access and retrieve flag. Okay, my name is anonymous. There's no password. Just allow me in, please. Then let's show. Okay, what if I don't go into ASCII mode? Because I've not done that before. I don't remember doing that. So what if I just get, what is it that I have to get? The flag, right? Flag.txt, invalid command. Okay. Was it not get? It was get in flag.txt. Okay, we got it, I think. So exit. Okay. Sorry. Fast FTP. I think this is the flag. Just got downloaded. Yeah. Okay. SMTP. Sending email. Okay. As with browsing the web and downloading files, sending emails needs its own protocol. Simple mail transfer protocol defines how a mail client talks with a mail server and how the mail server talks with another. The analogy for the SMTP protocol is when you go to the local post office to send the package, okay, to greet the employee, hello, good morning, to tell them where you want to send your package and provide the sender's information before handing them the package. Depending on the country you're in, you might be asked how to show your identity card. This process is not very different from an SMTP session. Let's present some of the commands used by your mail client when it transfers an email to an SMTP server. Hello or hello, okay, mail from, specifies the sender's email address, RCBT2, who's going to receive this, right? Data indicates that the client will begin sending the content of the email message. Dot is sent on a line by itself to indicate the end of the what. The terminal below shows an example of an email sent via telnet. Okay. The SMTP server listens on TCP port 25 by default. Do you know what I feel? I feel like I should be taking notes of this. Okay, next. Networking core protocols. Okay, so SMTP server listens on TCP port 25 by default. It's important to know this, right? Because I might do some CTF where I scan some ports, and if I do find something like this, I could just exploit this, right? So let's keep going. Obviously, sending an email using telnet is quite cumbersome. However, it helps you better understand the commands that your email client issues under the hood. Now, Wireshark capture shows the exchange in colors. The client's messages are in red, while the server's responses are in blue. Hello, client DHM. Okay, hello, client DHM. Mail from. Okay. Receipt to. Okay, accepted. Data enter message ending with on the line by itself. From. Okay, this is the message and this marks the ending. 250. Okay. Yeah, okay, example closing connection. Okay, now that we have covered some basic HTTP, FTP, and SMTP commands, you should have gained a solid understanding of how protocols are designed and used. It should be effortless to learn how other text-based protocols such as POP3 and IMAP work. Which SMTP command indicates that the client will start the contents of the email message. Which SMTP command indicates that the client will start the contents of the email message. Which? 250, okay. Hello? Is that it? Or hello, right? What? Which SMTP command indicates that the client will start the contents of the email message? Oh, data. Yeah. What does the email client send to indicate that the email message has been fully entered? A dot. Okay. POP3. Receiving email. You've received an email and want to download it to your local mail client. Post Office Protocol version 3, POP3 is designed to allow the client to communicate with the mail server and retrieve email messages. Without going into in-depth technical details, an email client sends its messages by relying on SMTP and retrieves them using POP3. SMTP is similar to handling your envelope or package to the post office, and POP3 is similar to checking your local mailbox for new letters or packages. Okay, some common POP3 commands are user identifies the user, pass provides the user's password, yeah, staff requests a number of messages and total size, lists all messages and their sizes, retrieve the specified message, marks a message for deletion, quit, ends the POP3 session applying changes such as deletions. In the terminal below, we can see POP3 session over telnet. Okay. Okay. Then the next one is, what is it? POP3, right? POP3, TCP port 110 by default. Right? Okay. Next. The exchange below retrieves the email message sent in the previous task. Okay. So you can issue some commands here. Oh. Okay. Someone capturing the network packets would be able to intercept the exchange traffic. As per previous Wireshark captures, the commands in red are sent by the client, and the lines in blue are the servers. It is also clear that someone capturing the traffic can read the passwords. That's no bueno. No bueno. Connecting to a POP3 server requires authentication. Use the following login credentials when needed. Linda and pass 1 to 3. Okay, so let's connect, right? So how do we connect? Well, we issue telnet 10.10.2.8 on the default port, and then client. Okay, looks like we've connected. Oh, okay, I have to issue that out. Okay, plain. Okay, user. The user is Linda. Okay, he agrees. The user is Linda, as in pretty in Spanish. Huh. Okay. Then we get the pass. We get the pass. Then the pass needs to be this one here, right? It's gonna be $PA $123. Okay, logged in. We're in. Okay, stat. What if I print stat? Okay. Then if I do list, okay, we get 4 messages. What are we looking for here? Looking at the traffic exchange. What is the name of the POP3 server running on the remote server? What's the name of looking at the traffic exchange? We'll retrieve the 4 messages. Oh, here's your flag. Okay, looks like we got a flag. Okay, this is to connect to POP3 server. What is the flag contained in the 4th message? We already got it. Looking at the traffic, what is the name of the POP3 server running on the remote server? The name of the remote server. By example.htm. What? Oh, Linda at server.htm. Looking at the track, what is the name of the POP3 server running? What is the name of the server? Well, that's just something that we will have to look into. What is the name? What is the name? What is the name? It has 1, 2, 3, 4, 5, 6, 7 letters. Server dot nope. It's the one. SMTP. Hello. Could it be client? Could it be client? Nope. Not client. Deliver date Linda. User return that below to Linda's server. Hint, please. Use your favorite search engine for the word next to Ubuntu. Looking at the what is the name of the pub running on the remote server? What? For the word next to Ubuntu. Oh, okay. And what is the word next to Ubuntu, sir? Oh, okay. What is the name of the POP3 server? I guess it is Dovecot. Yeah, okay. I see you. I see you. And let's look it up. Dovecot, the secure IMAP server. Okay, that's the name of the server. Okay, got it. Next. IMAP synchronizing email. POP3 is enough when working from one device, your favorite email client on your desktop computer. However, what if you want to check your email from your office desktop, computer, and from your laptop or smartphone? In this scenario, you need a protocol that allows synchronization of messages instead of deleting a message after retrieving it. One solution to maintaining a synchronized mailbox across multiple devices is Internet Message Access Protocol. IMAP allows synchronizing read, moved, and deleted messages. IMAP is quite convenient when you check your email via multiple clients, unlike POP3, which tends to minimize server storage as email is downloaded and deleted from the remote server. IMAP tends to use more storage as email is kept on the server and synchronized across the email clients. The IMAP protocol commands are more complicated than the POP3 protocol commands. We'll list a few examples below. Login. Okay, we authenticate the user. Login receives two parameters: username and password. Selects the mail folder to work with. Fetch the mail number and the data item name. Example fetch 3, and then the data item name to fetch message number 3, header and body. Okay. Move sequence set mailbox. Move the specified message to another mailbox. Copies the specified message to another mailbox as well. And then log out. Knowing that IMAP server listens on TCP. IMAP TCP port 143 by default. We will use the telnet to connect to ports 143 and fetch the message we sent in an earlier task. Okay, so I just want to exit. Okay, damn it. Okay, and knowing that IMAP server listens on, okay, so let's connect again. 10.10.202.8, and then on the port 143. So trying, okay, on to the next 10.10.202. Oh, I was connecting to the wrong server. Okay, so escape character is okay, capability. ID enable literal starts out plain, Dovecot, Ubuntu ready. Okay. Knowing that IMAP server listens on, we'll use telnet to connect. Okay. Logging Strategos. Screenshot below. So are you gonna give any credentials? Not really. The screenshot below, what does it do? So you provide basically login, Strategos, and then I guess the password, right? And then okay, capability, blah blah blah, logins enable title, okay. Select inbox, and then you get some inbox and 4 accesses. Fetch body and then passing, okay. Okay, hello, I'm wishing to send you an email. Okay, fetch completed. Okay, yeah, sure. Screenshot below shows the exchange messages between client and server resting from Wireshark. The client only needed to send 4 commands shown in red, and the lone server response are shown in blue. login strategy goes in the password, and then you get to select inbox. Okay, fetch tree body. Okay, log out. Aha. What IMAP command retrieves the fourth email message? Well, the fourth, that would be fetch for body, right? For body. Am I wrong? No, I'm not. I'm never wrong. Okay, next. Conclusion. In the previous room, we discussed the Telnet protocol. This room focused on other fundamental protocols, DNS, HTTP, FTP, SMTP, POP3, and IMAP. With the protocols covered, we now have a better understanding of how domain names are resolved, how web pages are served, and how email is sent and received. Another primary purpose of this room is to give you a good understanding of how a protocol functions behind the graphical interfaces. The table below summarizes the default port numbers of the protocols we have covered so far. Okay, that would be actually. Oh, I shouldn't have done that. I did want to do this. Okay, so let's just grab this, paste it here. Networking core protocols. Default port numbers. Okay, we got it. Now let's join on the next one. Okay, guys, this is all for this module. Let's see what we got here. Cybersecurity, more of the same, guys. Okay, let's see. Let's finish this. Thank you guys for sticking with me. I'll see you again at the next module from TryHackMe that we will tackle.